All right, welcome to our lecture on sedimentary rocks. Um, Sedimentary rocks are fairly important regarding the rock types that we go through in this class compared to igneous rocks and metamorphic rocks. The reason being, the majority of the surface of the Earth has sedimentary rocks on them. Most of the crust is igneous rocks, but the stuff on the surface of the crust, it's sedimentary rocks, and we get a lot of natural resources out of these things, and they just affect our daily lives more than anything else. Plus, here in Arkansas, the rocks that are actually around us outside, they're sedimentary rocks. So they're fairly important. I want you guys to focus a lot on this chapter. It may be the most important chapter in this entire course. As far as what you learn, I will lean heavily on this on the test. Just because it is the stuff we see outside and it kind of affects us the most. We get oil and gas and natural gas out of these sedimentary rocks, so they're fairly significant. So here's what I want to go through. We'll talk a little bit about sediments, how there's kind of two different types of sedimentary rocks. And it'd be kind of fun. Maybe we'll have a discussion topic about how, we do have three rock types of sedimentary, igneous rocks, and metamorphic rocks. I always like the little mind game of like, hey, what do you think it should be different? Should there be a fourth type of rock, or should metamorphic rocks just be lumped in with igneous rocks, or what? Anyway, one of the arguments could be that chemical sedimentary rocks should be their own rock type. I don't necessarily think this should be the case, but it's fun to argue. Anyway, so we'll talk about that. We'll talk about how we actually go from weathering like we'll call it a parent rock, and then turning it into a sedimentary rock. You should have read about weathering and erosion in the previous chapter, chapter 5. We'll talk about detrital rocks, which are also known as clastic rocks. Another way to think of this is the rocks that are made out of chunks. That's kind of how I teach it. And how there's texture and composition, just like we talked about texture and composition in igneous rocks, right? Right, we'll keep hearing this. We'll talk about the chemical rocks. We'll talk about sedimentary structures. That may actually be in a different video. I may kind of stop right around here and make all of this into a second video, but we'll talk about sedimentary structures, which are basically weird things we find in sedimentary rocks. Think of the real simple thing would be something like dinosaur footprints. That's a sedimentary structure. Ripples. It tells us that the water was moving on top of this sedimentary rock. Anyway, we talk more about their formation and kind of how we interpret this stuff. And the neat thing about sedimentary rocks is, we can look at an igneous rock and say, oh, this, cooled on the surface of the earth and maybe it came out of a volcano, or this one cooled inside the earth and, it's a granite. The neat thing about sedimentary rocks is they tell us about depositional environments. So you can find a sedimentary rock and be like, oh, this was part of a beach, or, oh, this came out of a river. And so it's just a little more, I don't know, it's a little more personal. And you can sort of reconstruct what the world looked like and things we can sort of relate to. Anyway, so let's talk about sediments and detrital and chemical sedimentary rocks. And yeah. So, detrital. It's loose, solid products originating from weathering and erosion. If I beat up a piece of granite, if I have a piece of granite and I beat it up, here's a granite mountain down here, right there. There we go. The granite mountain. Bang, 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 bang. I bang it up into little rocks and it starts falling down the hill. These pieces may eventually come settle down here, settle all the way down here, get buried and become a sedimentary rock. And it's made out of all the pieces of this granite mountain that I just beat up. That's a detrital sedimentary rock. Or another way you can think of this is detritus. Or also, we'll call these detrital sedimentary rocks clastic. I don't know. I kind of like the word clastic better. So you'll hear me use these two terms interchangeably, and you also hear me, use kind of a layman's term of like, hey, it's chunks. These are the sedimentary rocks that are made out of chunks. So chunks, detrital, clastic chunks. These are usually the sedimentary rocks that you think of when people think about sedimentary rocks, with kind of the exception of limestone. Limestone is a chemical sedimentary rock, and so you learned in weathering and erosion that we can chemically weather a rock, so we can dissolve, let's say, a limestone, or we dissolve calcite. You may remember calcite. You have dissolved calcite when you put acid, hydrochloric acid, onto that calcite. You'll notice some of those little samples we looked at were actually, would have little pits in them because people just keep putting acid on it, and it's actually dissolving away. So that doesn't just go away completely. Those ions will end up in a solution, and in kind of the case of nature, it'll usually end up in the groundwater or just the water running off where the rain hits, and these ions will be dissolved in that water. And later on, they may travel down, travel down to wherever the sea is, or to a place where that water will end up, and we can actually start depositing sedimentary rocks. So if you get the chemistry enough to where you can sort of regrow the rocks that you chemically weathered before, you can start to kind of regrow them again. The best example I can give you is salt, right? We can go take a pan of water, put it on the stove, and we can dump a whole bunch of salt into it and stir it up. You can't see the salt, right? The salt dissolved into the water. Now let's crank up that stove and start boiling off that water. If I start boiling off that water, there'll be so much salt eventually in the water relative to the actual water, right? You'll have more NaCl, sodium chloride, that's what salt is, halite, right? Compared to all that H2O water, the water, it'll be super saturated in that with respect to that salt, and those little ions, the NaCl, will start to be able to find each other again and start to bond again. And it'll start growing salt crystals, also known as halite. So this is kind of what we're talking about when we're talking about chemical sedimentary rocks. It's not just salt that does this. Something called calcium carbonate does this, and that's what a lot of little seashells are made out of. It's what coral is made out of. It's what limestone's made out of. So we've got the chunky stuff called detrital sedimentary rocks, and we've got chemical sedimentary rocks. So kind of going back to detrital sedimentary rocks, how's that work? How do we actually get pieces of a rock and then turn it into another rock? Well, the thing with sediments is they come in different sizes and they travel. So how we classify sedimentary rocks, and in particular the detrital or the clastic sedimentary rocks, as we look at their grain sizes. I've kind of talked about grains a little bit in igneous rocks, but it's the individual pieces of sediment. And it's all about the size. So one size, the biggest size, is gravel. I could say the word gravel, and you can probably have a picture in your head of some gravel on the side of the road or something. Here's some gravel. And you may be like, dude, that's pretty big. I don't know how to call that gravel. Well, as far as geologists are concerned, we sort of lump all the big stuff into just gravel, usually. Engineers will break these things up into different sizes and call, oh, these are boulders, and when they're less than a foot wide, we'll call them pebbles and gravel or whatever. I've gotten into fights with engineers before about things like this. But as far as we're concerned, anything bigger than 2 millimeters across, 2 millimeters, anything bigger than 2 millimeters across, we will call gravel. The next size is sand. If I say sand, you probably get an image in your head of something like that, like sandcastles or something. If a sediment is smaller than 2 millimeters, which if you blow up this YouTube video on your laptop or computer screen, this little red dot is actually about 2 millimeters wide. But sand is from about 2 millimeters wide to basically down to where you can just barely see it. And it's kind of convenient that that's the fact. I'm not going to make you memorize the different sizes between these sizes of sediment, except for 2 millimeters. Because anything bigger than 2 millimeters is gravel. Anything smaller than 2 millimeters that you can see with your naked eye is sand. And anything smaller than that is silt or clay. So, Silt and clay are sediment sizes that you cannot see with your eye, or it will be very, very, very hard to at least see silt with your eye. We have to get a microscope to start seeing the grains of this stuff. And you're looking at this picture and you're like, this is scary looking, I don't know what any of this is, I don't know what that is. And you say, wait a minute, what's this? I recognize this word. This was a mineral. This is one of our minerals. This is that white chalky thing. And I'd say, yes, it was. It was one of your minerals. And you'll remember, it's just this white chalky thing. You're like, there weren't any crystals in that. It was kind of weird. It was like chalk. Well, that's because it's a whole bunch of these little clay minerals. We call these things clay minerals because they have these little laminar crystals, right? And they're tiny. And they're kind of flat. And when you get a whole load of these things and squish them, they turn into a special kind of rock called shale, which is just kind of really called laminar or sheet-like. Maybe sheet-like is the best term I should use. But you can kind of see how this stuff is sheet-like. And if I took all this stuff and like compressed it really hard, how it would all kind of line up sideways. But this is clay. So to kind of take this stuff and classify it, here's the sizes over here in millimeters of these different sediment sizes. Like I said, we don't really care. You don't need to know these. I care that it's gravel. Anything bigger than 2 millimeters is gravel. And when it turns into a rock, we either call it breccia or conglomerate, depending on how rounded its particles they are, but we'll talk about that in a little bit. Anything below 2 millimeters is either sand, silt, or clay. This stuff ends up just being mud. Mud is what you think it is. It's mud. Sand, when it turns into a rock, is called sandstone. Very profound. Nice and convenient, isn't it? It's a little bit simpler than igneous rocks, I think. Silt, turn it into a rock. Siltstone, as long as the grains are mostly silt, it's kind of hard to tell, when you're looking at that rock. And then clay, if you turn it into a rock, we get shale. So, you say, Travis, when I've got a sediment, how do I tell the difference between silt and clay? How do I tell the difference between a siltstone and a shale, or maybe a mudstone? Well, here's the nifty thing about geologists. We use all of our senses, and yes, I've done this in the field. When I want to tell whether a sediment is more silty or clay, I put it in my mouth, and I'll grind it, just a little bit of it. I'll take like a bite of the rock or a bite of the sediment or whatever, a little bit, just enough to get in my front 2 teeth, and I'll run my front 2 teeth together, and if it's silt, it'll be gritty. It'll be kind of, and you can tell that it is gritty, almost sandy. Clay, however, will feel smooth. It'll almost feel like there's nothing between your teeth. You'll just be able to taste it. It'll be weird. I'll go into a story in class if you remind me about how one time I dug out this little clay layer called bentonite, and it tasted exactly like peanut butter. It was kind of funny. Yeah, so we can take that stuff away, and we just have the gravel and this stuff. So this is really what I want you to learn. This is what I want you to know. So again, bigger than 2 millimeters, it's gravel. Smaller than 2 millimeters, it's sand, if you can see it. If you can't see it, it's silt or clay. Cool? Cool? Questions? Good. So we've talked about weathering. We can weather a big piece of granite or something else. We turn it into these little sediment pieces, which are classified by their size. And then we have erosion. And you'll remember that weathering is something that kind of happens in place. It happens to an individual thing. You can weather a rock in place. If I have a rock sitting on a table and I beat it with a hammer, I'm weathering it. However, if I then tilt that table over and the rock and the pieces that are left of it fall off the table, that's erosion. Erosion is kind of a transportation. So let's talk about transportation. So when we have these sediment pieces and we start to transport them, that means we move them, usually due to gravity, under the influence of water, it'll actually start to sort the grains of sediment. So how's that work? Well, I'm kind of a big guy. I play soccer. I have these really dense thunder thigh legs. If you drop me into kind of a slow moving stream, I just kind of sink. I don't really go along with the stream. However, some of you who are lighter than me and maybe don't eat as many hamburgers, you may float easily down the river. So if we take everybody in class who's like as big as me and dense as me, and we throw us into a little stream, we'll all go boom, and we'll just kind of sit there and all be together sitting there near that river, but everybody else may start floating down the river. So now we've sorted out our classroom of people, and all the kind of the bigger people like me will be sorted into one spot, and all the lighter people will be continuing on down the stream. That's sorting. It happens with sediment as well. Hopefully that's an example. Wasn't too bad, but that sorting, the heavier stuff settles out first, and then the lighter stuff will continue on down. So here's kind of a little drawing. You can imagine this is a microscope. We're looking at some sediment under a microscope, and we could even identify, oh, there's these sand particles because they're this size, and there's silt because it's this size, and there's clay because it's tiny, tiny, tiny. Is this, would we say this is well sorted or poorly sorted? Take a moment. What do you think? Are you thinking? Do you have a guess? This is poorly sorted, right? There's different grain sizes all over in here. It's not very well sorted. Here is an actual, what we call a thin section, which is basically what you're just looking at. This is a real one. And so this is poorly sorted, right? We can see these huge grains of sand, and then there's this smaller silty stuff. And in between it, there's like clay that we can't even see. It's just kind of the background stuff. So poorly sorted. What about this? These are this is kind of a blown up view, a magnified view of of some sand. And look, all these little things are all the same size. Therefore, this must be well sorted, right? And if we turn this into a rock, we definitely call it a sandstone. And these little grains, these are actually quartz. How do I know that? Well, I kind of know what quartz looks like. You look at it enough, you know what it looks like. And we'll talk a little bit more about that, about what happens with weathering and erosion with respect to quartz. Because quartz is so hard, when you're actually weathering a rock and weathering sediment, quartz is the stuff that will kind of survive forever. Everything sort of weathers down into nothingness, or clay, or ions, except for quartz, because quartz has a hardness of 7. I mean, we use sandpaper to kind of, rub things down, right? We'll sandblast something to smooth it out. That sand is quartz. It's the leftover stuff from all the weathering. But that's kind of an aside. This is well sorted. This would eventually turn into a quartz sandstone if we buried it. So there's the sorting, well sorted and poorly sorted. This tells us something about its transportation. This stuff has gone a long way. All the smaller stuff is left. All the bigger stuff is left. This has traveled a lot. This, on the other hand, and this probably hasn't traveled very much from where it first came from, and just kind of fell down and plopped down somewhere and didn't have a whole lot of transportation. Rounding. So there's something with weathering and erosion called abrasion. And so if you're transporting all this material down a river, or even throwing waves over it, that's kind of moving sand over it as the waves go back and forth, you're abrading these rocks, kind of like sandpaper, like you're just rubbing sandpaper all over them. So you're rounding them. Do these rocks look rounded to you? Sure. Those look rounded. That looks rounded. What about this one over here? Okay, yeah, that one looks like it's broken. It looks like it broken. Maybe it got broken not too long ago and it hasn't been rounded yet. But you give it a while sitting here and you throw the waves on it or the river on it or wherever the water is coming from, and you may round this just like you've rounded these other ones. While we're talking about it, is this poorly sorted or well sorted? Or is it in between? What about this? Well-rounded? Not well-rounded? Not well-rounded. We use the term angular. Are these things angular? Yeah, there's some angles in there. I see some 90 degrees and sharp, acute angles. But just about every angle's got a little bit of a rounding on it. So maybe we'd say these are, sub-rounded or moderately rounded or something like that. Is this poorly sorted or well sorted? I agree. This looks well sorted to me. All these are about the same size. Uh, the rounding's pretty good, but I mean, these aren't all super circular. But due to that rounding and that sorting, I'd say this has traveled a pretty fair amount. Not super far, but it's undergone some transportation. Now here's a fun picture of all these little giant pieces of gravel or boulders, if you want to call them that. You can definitely see these have been rounded. It's not hard to guess why or how they've been rounded. It's the waves coming up here, just moving all the smaller pieces of sediment across them and moving them into each other, and they hit each other, and it's just like that little rock tumble you got when you were a kid, um, and you tumbled your rocks in them, and it rounded them, if those things even still exist. What about this? This is a rock you'll have in the stuff you're supposed to identify. It's called breccia or breccia. Feel free to pronounce it either way. Uh, and you notice this is the actual rock. This isn't sediment anymore. This is sediment that turned into a rock. These are big grains. Here's a little scale right here to kind of give you an idea of how big these grains are. I assume each one of these is a millimeter. Well sorted or poorly sorted? Poorly sorted, right? There's all different sizes. There's mostly this white stuff. It's all the same kind of rock. But there's all different sizes from really small that you can barely see to really big stuff. So poorly sorted, and they're angular, right? Sharp, 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 sharp edges, sharp edges, sharp edges, sharp edge, sharp edges. So this when it was a sediment, it didn't get transported very far, right? This fell off a rock somewhere and got buried and became a rock. Didn't go very far. So this is kind of a little summary of the stuff we've sort of been talking about here. Let's pretend we have a source area up here. This is some granite mountain. Maybe this is in Colorado somewhere. You have some weathering that occurs up here. You know, things freeze, cracks happen, earthquakes. You just weather this stuff. And it starts to erode. It falls down the mountain. It rains on the mountain. There's creeks on tops of these mountains. Or just kind of generally falls down the mountain because of landslides and mass wasting. That's chapter 9. But the bigger stuff will kind of potentially settle out up here. If you've hiked near tops of mountains, you know there's big rocks around. And over time, these things will start to get more rounded. They will get smaller. They will get more sorted. You'll end up down to the sand size of things. And at this point, you know, we could even draw like a little, you know, like water right here and say that, oh, now we've reached the beach when we get right here. And this stuff will shoot out and actually get deposited way out in the ocean somewhere where sand will get deposited kind of around beach areas. But this is kind of the direction of transport and kind of shows you, you know, roughly how things settle out and get deposited. So some things to think about are the farther away your source is, the more sorting and rounding you get, the more transportation you have. So when we have a place like the Rockies, and let's just say, you know, the Denver area and Pikes Peak and all that stuff, if you've been over there, those rocks, when they weather and erode, they end up, a lot of them in the Arkansas River. And they flow all the way down through Kansas, right? Right? Don't quote me on that. Flows through Kansas and then flows down to Oklahoma and then over here into Arkansas. And then that river goes up and meets with the Mississippi River, and then it goes down into Louisiana and goes out in the Gulf of Mexico. That's a long way. The Arkansas River is a very long river. The rocks that are in there go through a lot of transportation. They're beating against each other. They're abrading against each other. Anything in there that's not quartz basically gets beat out of it. It dissolves. The only thing that's left when you get to the bottom of the Mississippi River is quartz sand. So you have these really well sorted beaches around there where it's just kind of this yellow quartz sand, yellow and clear quartz sand. The opposite of that is a place like California, where the mountains are right on the coast. Not a whole lot of transportation happens, and you can find like pink beaches where there's lots of feldspars and other minerals that didn't actually get obliterated in the transportation process. Kind of neat. So, deposition, we're talking about transportation. Now, we've transported down our mountain and we're depositing somewhere. Here's a fun little image. Here's a little quiz, and you can even pause the video if you want. Which way is the river flowing? Can you tell? I had to look at it for a while to figure it out. Feel free to pause. We'll talk about rivers later on in the class. We'll spend an entire lecture on them because rivers are cool. And they're around here, and a lot of people float rivers, a lot like this one. Anyway, so you'll notice there's a whole bunch of sand right here, and maybe it's gravel. I say it's sand. Do I really know? I'd have to get down there and look at it to be a proper geologist. But this is being deposited right here. What you're seeing is that water, this river flows this way, and there's sediment in this water. And the more water that's in here, the faster it's moving, the more sediment it can carry. So when things are flooding, there's a lot of sediment that's in this water. But as it comes around these bends, the water on the inside actually kind of slows down. It's less, the water doesn't have to travel so far on this inside, or on the outside it has a long way to go, so the water actually speeds up. But in here it slows down, so any sediment that's in this river when it's up here and flowing around this bend, it'll actually drop out because it slows down. It's being deposited, and over time it gets buried and buried, and this river will actually kind of grow up over time, or it'll meander over time. It'll migrate sideways. We'll talk about that later. But you can get these river deposits, and the fun word for that is fluvial. Don't worry, that's something we'll visit later. But we're depositing this sand here, or maybe gravel, and it's usually pretty well sorted. Burial. So now let me back up a little bit. I gave the example here of a river. Most rocks, most sedimentary rocks, get deposited on the ocean. When we go look at big rock layers outside, when you see them around here in northwest Arkansas, they're being deposited along the coastline or just off the coast. River deposits do exist. They're a little bit harder to find. So I just want to hit that point home. When you see a big sedimentary rock, see a big old layer on the side of the road or something, on a road cut, it's probably deposited in the ocean. So we've deposited this stuff, and in order to turn it into a true sedimentary rock, we got to bury it. We got to give it some pressure. So this is kind of the whole process: erosion, deposition, compaction, and cementation. We've got our little mountains up here. We've got a river coming out of the mountain, and it's dumping all this sediment over here over time. And as more sediment comes in, it pushes down the sediment that was already there, and more sediment, and you get layers and layers and layers and layers. And so you've deposited, you've started to compact, and then you get cementation. And I could probably say cement, and you know what I'm talking about. And you kind of know how cement works. You pour it out, and it starts to harden, right? When it hardens, it's kind of gluing itself together. Very similar process with rocks. You compact the sediment, you start to cement in it, and what happens is you kind of get groundwater flowing through this stuff. It'll have a lot of ions in there. It'll have a lot of little elements a lot of the time. It's actually the same elements that these little rocks are made up out of, and the minerals will grow in between those little grains of sediment, and it'll lock it together. I mean, we could take that saltwater analogy again. We could say, hey, you know, we could put in a bunch of salt water into a bucket and then throw in some gravel and then boil off all the water that's still in that pan, and the salt will grow between the rocks, and it'll actually harden it. It'll cement it. And we'll be like, oh my gosh, we just made a rock out of some sediment. Usually, cementation isn't done with salt. It's usually silica, you know, SiO2, quartz, and sometimes it's calcium carbonate. Those are usually the big two. So, ignore all this. This is basically stuff we've been talking about. What I chose this picture for, and it's kind of hard to find, is again kind of that transportation. And we're kind of looking at a coastline right here. And what I want to just sort of hit home is that when a river ends up meeting the coast, the water velocity slows down, right? The water hits the ocean and boom, it stops. So you can imagine all that sediment starts to fall out of the river. Well, the heavier stuff falls out first, which is the gravel, if there's any in there to begin with. Then the sand will start to fall out. These are why our beaches are usually made out of sand. Then, as the kind of water comes out, a lot of times you'll see kind of a plume of clay and silt, and then that stuff will kind of deposit. And out here we've got limestone. Well, this is a chemical sedimentary rock. Now we're kind of talking back about the chemical sedimentary rocks again. Here's the deal about limestone. It's made out of life. You find lots of fossils in limestone, and some limestones are made completely out of fossils. I'll show you some. They're pretty common. It's called fossiliferous limestone. Very simple. Uh, Limestone will form a lot because of coral reefs. You can imagine if you're a coral reef, you don't want to be living back here or back here. Why? Because you've got clay and sand and silt that's just falling out of the water and it's falling all over you. You're not going to be able to grow very well and survive very well while the water's all murky and muddy. You want to be out here where, hey, there's some sunlight and the water's not so muddy. So we'll find limestone sort of growing and forming in areas that sediment isn't collecting. So if there's no river right here to begin with, that's just dumping into the ocean, this limestone will be all the way back up here where the coastline is. Yeah. So here's a good example. You may recognize what this is. This is Lake Pontchartrain. I used to live somewhere up here. This is Louisiana. This is the Mississippi River. LSU, I think, sits right there. Boo, Tigers, boo. Anyway, you can see where the river comes out here at the Bird's Foot, and it's just dumping sediment out into the Gulf of Mexico. You can see all that silt and clay, right? Pretty neat. And there's another river over here that's doing something similar. Now, it doesn't always look like this. This was probably after some big rain and storm event that's just dumping and dumping and dumping tons of silt and clay all over the place. But you can see how this stuff just floats out here. It's so light, the particles are so small, but it eventually gets out here and it will settle down on the bottom of the ocean, and it'll start to deposit, and it'll get buried over time. And so out here in these regions, if we dig down, we'll probably start to find shales forming, or siltstones, maybe a little closer in. Or we get really closer in and we'll start to find sandstones forming. Hey, look, there's some sandy beaches. You can see the yellow. And these are called barrier islands. We'll talk about how those things happen later on. But kind of neat. A little zoomed in version. Again, all that sediment, all that clay and silt just dumping out of there after that delta. And just imagining that stuff sort of settling down. Now the gravel and everything, there's no gravel in there. The gravel's settling out either way back up the river somewhere, or, you know, out here where the river starts to actually get out into the ocean. So, lithification to a rock. Lithification means lithifying. Lith is what, Greek for rock? Maybe it's Latin. I forget. I'm a geologist, not a language guy. So, lithification into a rock. And again, I've kind of mentioned about cementation. This is just kind of showing it. You deposit a sediment, you squish it with overburden, you bury it, you squish it, and over time, little minerals will start to grow in there if it's kind of super saturated, and it'll actually cement itself into a rock. Yay, sedimentary rock. Yay, sedimentary rock. All the little grains of sand are in there. This is actually something we'll talk about here in a little bit, probably in the second video I do. This is a sedimentary structure that you see right here. But hey, sedimentary rock. All the sand is together now. So, want to talk about this? This I think I'll leave more to lab. We've talked about texture and composition, so we'll actually start to look at the different types of detrital sedimentary rocks. We'll have some chemical sedimentary rocks that we look at, and we'll figure out how we actually classify these things and the differences between each other. But we'll go ahead and leave this for lab. If you've got any questions, go ahead and email me, get on Canvas, however you want to do it. And I will respond to this. And you know what? Let me know if you like this better than the other modules I've been creating. I assume that you do, because this is kind of my first one, and I'll probably do more of these in the future. Anyway, that's all for now. I will post a second video going over the sedimentary structures and what formations are. And kind of interpretations of depositional environments based on the rocks that we see.